for visual testing, and I will mention 2 of our projects. We were facing some challenges there and how we cope with them. Then I'll also share with you some specifics or what is different if you focus on visual testing or visual of your apps, and how which tool could be used. And the last one, I would like to show you some live demo. I didn't prepare any recording. I didn't prepare any anything like prepared and recorded, so I hope it'll work. So let me start first with the first section or first part, which is the importance of the visual testing. And it's my favorite approach. I always starting with something outside from the testing topics and testing domain. So I decided to go for one topic, which is the favorite electric car, Tesla. Tesla produced about 90,000 cars last quarter, which means it's about 100 per hour they produced, and they plan to sell as well. If you check the numbers, they are trying to sell the same amount, within the same quarter or the following quarter after they produce that. And the average price is 33,000, or not average, but base price is 33,000 US dollars. And what is the specific or what is special about this company? They are the only company trying to sell their car exclusively online. They don't sell their cars in the store. Of course, they have some showrooms. They'll show you the car, but they are selling the car only online. There are also some other companies like Mercedes. They are trying to offer online purchasing for their cars, but Tesla is the only one, at least according to the Business Insider article in July 2019, which selling the car online. So for them, having a good e-shop or the purchasing application is really crucial. And not only functionally, but also visually. As you know, this is the expensive car, so they cannot afford to have some horrible web pages, not nicely looking pages. So if you go to their website, the page might look like this one. But it's so easy, and let me maybe show you the first kind of, let's call it demo, some kind of example, how easily you can break the web page. And I'll use my prepared browser and open the website. This is the website. If you go there anonymously, you need to choose the region where are you coming from, and this is their website. And if I open the developer console and try to simulate one typo in the code, somebody is joining us. Okay, I'm adding the new guest, and let me check also chatting window. Hopefully everybody could hear me. Yeah. So just quick check. Maybe some of the colleagues who could unmute your mic. Could you now see something else than the presentation, or you are still on the presentation?
We can see the presentation.
Only presentation. Sorry for that. I'll need to switch to share you the whole desktop. Then it will be better. Okay. So I'll restart the explanation. So this is the Tesla website. This is the their landing page. And what could happen that some developer do the really stupid mistake, and let me find that. One more. Imagine that some developer made a typo. I hope this is the one. And instead of link to the folder with CSS file, there will be something completely different. So then the website would look like this one. So you might imagine that this one is not the best or nicest web page Tesla could deploy. And why I'm showing this one, these days companies are trying to implement continuous deployment. So they are often having automated testing, and if this pass, they just go directly to the production and deploying. So they could easily introduce this small mistake into production, and the web page would be completely broken. And what is the paradox? I'll switch back to my slides. What is the paradox? That only this small typo in your link to the CSS file could cause this kind of mistake or this kind of failure in the production. But if you have implemented Selenium-based test automation, the automation tool could easily navigate through the page and all the functional testing would pass. But visually is not correct. But your automated tests passing because there is no any issue with DOM, the document object model, via testing and interacting via web browser. So this is one thing which could happen. I know that this is a bit extreme example and it's really stupid mistake, but imagine this could happen or some other issues could happen. Of course, there are different kind of things which we cannot easily find using functional testing, but this is obvious. Everybody could notice this one. But there might be some minor issues not easy to find by human eye. So, of course, you always need to discuss whether this has some value or whether this is important to do it in your context. Not all the organization need to do this kind of checking. And of course, for this example, it's not the thing where you need to have some complex tooling. You might easily find the bug, but there are some different one I'll show you later, which are not easy to find. So if I would go and try to calculate what might be the quarterly revenue, it would be 2 billion US dollars we could lose within the quarter. Of course, with continuous deployment, we could fix the issue very quickly. And hopefully, the companies are now able to fix it quickly. But in average, if this would happen and you would lose the production for 1 hour, then in average, Tesla is selling 100 cars per hour. So 1 hour outage with any mistake, visual or functional, might cause loss of sales for 100 cars in other from other point of view. So if we would go and follow the other topic I would like to share with you is what are the challenges, what really is, what are the difficulties we need to cope with. And one thing is that to test this in that fragmented world of so many devices, this is a pretty old picture, but it's still relevant. It's 5 years old picture and shows how the Android devices are changing within 1 year. Okay, hopefully.
So I'm inviting the people from.
Okay, thank you. So this is how the things are changing within 1 year. So you need to keep up and check whether your application is not sensitive or how sensitive it is. Of course, there are many modern frameworks which could address this, and you do not need to do the visual testing, but always it's good to be sure that your application is working properly on various devices. And of course, there are many versions of browsers on the desktop or computers. If you go to the browsers, like some kind of survey or analytics, there is a article showing how many devices or what is the current market share of individual browsers, resolutions, operating systems, and also device types. And you might see that if you would like to cover this, it's not easy because I'll now maybe switch here to cover 70 to 80% of global devices, or to achieve the 70 to 80% global coverage. You need to test at least 3 devices. You need to test 3 device types, 2 iOS versions, maybe 5 Android devices, and many other things you might see on the slide. If you would be interested, there is a nice article at browserstack.com website, so you can read that and go through that details. I'll show you one example we prepare for our internal purposes to show you how complicated or challenging it might be if you do the visual testing. These 2 pictures are not the same, and you probably noticed when I was switching there and back through the slides, where are the differences. But if you didn't, spend maybe next 5 seconds and try to find the differences. Then I'll show you later on the next slide what was the differences. So, and imagine that you would need to test this one. And we did this, we already spent several hours doing this kind of testing, and it wasn't the best job for the testers. So we decided to address this, and I'll show you later how we now cope with that with some tools instead of using our human eyes. So before that, I would like to show you what are the typical projects, because somebody could question and say, okay, but this is very special. We do not need to deal with that. I'll show you one, or I will show you 2 examples, and these are anonymized. So these are not the real one, because we are under NDA and we cannot disclose the details. But one of our customer building up their own car configurator, and we were asked to prepare several configurations, set up the devices, and test several configurations on these devices. The other one is, and I took completely different bank, not the one we were delivering the project for, and we were asked to test these different widgets on the new web page. And you might know, or you might guess which bank it was, because there are not too many, or actually there are many banks changing their website pretty rapidly. So maybe it won't be so easy. And in numbers, it was like, and you can imagine maybe based on that, what is the effort behind. For the new car configurator, we had 3 different models of the cars and 15 parameters of configuration, and we were asked to test on 24 devices. On the bank's project, we had 3 testing environments and more than 20 functional widgets like IBAN calculator or application for a mortgage and many others. And they were asked, they asked us to check that on 10 devices. And of course, this is not about the tooling, and of course, it is a stupid idea to go through all these things. And I'll show you what we did and how we cope with this, because this is the analytical work first. So you need to really assess the risk. You need to understand what is necessary to test and how deeply to go, to not spend thousands of hours or days doing that. So in short, if I would summarize what are the challenges, the device market is really fragmented and it's changing very often, I would say continuously. And it's not easy to set up configurations easily and maintain them. You know how often all the browsers are changing. It's, I don't know, there is 70 plus versions already of Chrome. And then the question is which one should be tested, whether the last 3 or 4 or 5, and how often. And if you are releasing your application, or even you are not releasing a new version of your application, you always want to be up to date with your devices. And the last challenge, I feel like the biggest one, it's really monotonous and repetitive work, which is pretty boring. And I think nobody would like to do it for a longer time. So you need to rotate the team there, or you need to find the tools to do it for you rather than asking testers to test these things by human eyes. So these are the challenges, and I will show you just a few topics where I feel like we need to adapt or we need to change the approach. And I decided to take these 3 areas. One is selecting the configuration. I will just quickly touch this topic and then I'll move to the testing types and test automation levels. Actually, I prepared a lot of demos at the end, so I'll try to speed up now because we are already in the middle of our webinar. So I'll really quickly go through that. And if you would be interested more into the methodology and you would like to discuss more in detail, I'm happy to organize one-to-one call so we could go more deeper into topics you are interested in more. So first one, selecting the configuration. What we do usually, we just check the production, try to understand where the sensibility of the application is, which kind of model could be more sensitive, or which kind of screen is pretty important. And also we do, as in any other areas, kind of risk-based approach or risk-based testing approach. This is one of the examples we used for the customer, where we were forced to test heavily various configuration. It's a few years old already, but I took it as a nice example where you can easily discuss with your customers what kind of testing you would like to do. And of course, you need to optimize. You cannot test everything. And on that time, we decided we will do the full scope testing in Internet Explorer 11. On that time, on Windows 7, this was something which was dominant, but probably it wouldn't be nevermore these days. And a lot of browsers already doesn't exist, and a lot of browsers are not used anymore. But this could be good way of discussing with the customer or with the business users what need to be tested. The agenda on the right side hopefully explain all the details. Basically, the empty circle is no testing at all. And sometimes this is not enough. Sometimes we need to also discuss how often to rotate or update this table. This might be the initial or first release before you go live, and then it's good. And we did that we randomly choose the scope and randomly test within each area where we didn't test fully, or where we didn't take the full scope testing. And I will not go to these kind of details because this is then just simple analytical exercise, and good test analysis is required to deal with that. Then the other thing, and I'll show you later, is the testing types or some approach you could take. One is that you just do simple and stupid taking screenshots and checking the results of that bitmaps. And the other approach we found also useful is extend your existing functional testing. I'll show you some examples I built up just for this presentation. So it might not be very stable, but hopefully it'll work for the purposes of explaining how it could work. But you basically take your existing test cases, automated test cases, and you just extend them by one extra step, which is visual check before you close the browser or you leave the screen at the end of your or on the last step of your test case. I'll show and explain later. Then if you go to this test, to the third one or third part of that specifics, or where I think there is something different than other approaches we take, is level of test automation. Of course, you can start manually, but nobody, I don't believe, could survive if your application is really sensitive on visuals to stay on manual level. Then we often use some cloud solutions like BrowserStack or SourceLab to simulate the environment instead of building up our own. Otherwise, we would be dying in maintaining and keeping up with all new releases and changes on OS level, but also on browser level. So this is good this is the easiest way to automate. You just purchase the cloud and that's it. Then the next level would be just taking the screenshots and then visually compare them. I'll show you this later. And then if you have this one, then it's the next level of maturity would be that you assess your screenshots against the baselines you collect or prepare before. And a fifth level of automation I call intelligent automation, where we dynamically recognize elements, and we could assess the screen based on some machine learning model, where we could recognize whether the logo is on the website or whether the login screen has all the elements required. I'll show you just example also on this level, but this will be just screenshot because this is what we are now prototyping and it's not ready for a live demo, but hopefully we will be soon able to show you this one as well. So if I would go or if I would structure these are the three clusters, like old-fashioned approach. Then there is something, and I'll show you three examples. Two of them are just links to existing commercial tools. You might go there; they will be happy to sell the tool. And one which we call Watch UI. It's open source, and you can easily implement in your environment if you would be interested on that. And then the prototype we also did on the fifth level, and this is more machine learning based approach. And the machine learning based approach is built up on top of a lot of open source tools, especially from the Google, but not only, and which is TensorFlow. And we also trying to inbuild this into our favorite robot framework. And with this tool, you can easily assess whether on the screen you can find logo or login button or whatever search button. And this is because of machine learning and AI implemented within the algorithm. We cannot assess that for sure. There is always some level of confidence. And you might see on the screen that there is a login, logo, and search button recognized by the tool. But this is still just kind of prototype we are playing with. I'll skip probably this one. And these are the two tools which are commercial. And if you are interested to do your visual testing, you could play with these two. Actually, the Apply Tools, it's I would say already well-known player on that area. There is SDK, so you can easily connect your C# or Java code into the tool. If you would be interested, we are happy to help you and assist you how to do that. Or you could use Percy, which is the other tool. All these tools have very nice UI, so you can play with that and click or set everything up by clicking. But I'm not very big fan of that because it's not easily scaled. Then, if you would follow the clicking approach, usually an automation it's not the best way doing that. Apart of these two, where I don't want to spend too much time because I think there are much better guys to introduce or explain how it works. You might find a lot of documentation and videos also on the web pages. I would like to show you something what we are working on. It's completely free. It's open sourced. It's I would say in beta release. We're still playing with a pretty raw code, but I think it's already ready to be used. This is something what we called Watch UI. It's a robot framework library, which we published I think last week, and you can find it on GitHub and easily download. I'll show you how it works, but not because of I would like to show you the tool, but you could easily see the principles, how your visual testing could be implemented within your test automation. And you might then use the same or very similar approach in Java, C# or whatever else. But this is based on robot framework and Python libraries we used. So as I said, it's completely free. There are 2 keywords to create basically pictures, which could be then used as a baseline to compare, and 5 keywords to check against that screenshots. One is to create screenshot. It's to create snapshot of entire browser. The other one is just take some part of your browser screen. For instance, you would like to check whether the logo is right one, so you just take the frame of your logo and comparing it against the baseline you took. For the comparison, we have 5 keywords. One is simple compare 2 images, where you have 2 images saved on your file system. Then the compare screen is for the comparison between the browser, which is open, with the screen you have saved as a baseline. Then you can compare just areas. Then you can compare the screens, but ignore some part of your areas. And this is completely and easy to implement. So I'm coming to show you 2 demos. One demo is for configuration visual checks. And now I'll switch to my IDE. I hope you could see my pie chart. Could somebody tell me yes or no, or should I check? Yes, thank you. So you see the pie chart. I'm not sure whether it's big enough. Let me try to make it quickly bigger. Hopefully you can read it. If not, the screen I'm sharing should be zoomable. So you should be able to zoom the screen I am streaming. So first, this is my scenario I would like to talk about. This is a pretty long demo, but I'll try to be quick. We are using robot framework. This is keyword-driven framework. It's open source based on Python. Sorry for the guys who know that, but I just wanted to show and explain before we will get lost in a demo. This is the structure, how it could look like. There is some settings section. You basically import all your libraries and do some setup. Then you have the variables. Then you have your test cases. My test case number 1 is called homepage. The second one is check homepage. Then you have some keywords you call. You might take these as methods for calling. And what else I would like to show with you is that there are some logs which are generated by the robot. I don't spend more time on this one. I'll start with the first configuration visual checks. What does it mean? This is the approach you could take in visual testing. We call it configuration visual checks. This is nothing else, just taking the pictures and validating whether the pages or mobile apps are displayed as you would like to have them displayed. And I'll show you a simple example. I took Spotify and I configured these in resolutions. These are basically pairs for screen resolution. And now I'll a bit jump to the slides and back here. I took these 10. Let me show you the screen. This one. I took these 10 shown on that graph on the left bottom side and just rewrite the screen resolution here. And what I did, I import our library, Watch UI, and I ask my robot framework to take 10 screenshots, basically. It's so simple that you do just this one. I write down robot test homepage and then refer to the file where I have these tests prepared. And once I run them, hopefully it'll work, it opens browser, adjust it to the specific or specified resolution as I defined, and take the screenshot, nothing else. But imagine that you would like to do these 10 screenshots by yourself, setting up the screenshots and taking the pictures, or at least validating these. Of course, there are some plugins on Chrome, maybe on other browsers as well, so you can easily and quickly adapt or adjust your resolution. But this is something which is done for me by the tool instead of me. And I could do something else if I'm bored by this, but it should generate, and I hope it'll work, it should generate these screenshots. So for me, this is not the best approach. I would open the browser and use something and manually check whether the screenshots are okay or not. This is still a very stupid approach, but at least you are saving at least a bit of your time adjusting. And you could do this by integrating Browser Stack or Source Lab and do the same screenshots across various devices, not only desktops, also tablets, mobile devices, and all the other things. But in order to make it simple for the demo, I don't integrate any cloud solution, but you could have hundreds of these and then manually very quickly check what's going on there. If I would like to validate whether the screenshots are okay, I took all these screenshots. I will now delete them, but I took it as a preparation into my baseline folder. So I have the same screenshots here, and I prepared simple test, which should be somewhere here, where I basically set up two variables, which I will use later, 720 and 1280, which will be future resolution of my testing. Then I set up resolution, which is basically nothing else, just concatenating the strings. And then I'm setting up the window to the size of this 720 times 1000 something. And then I comparing my baseline. This is actually the picture. I hope I have it here. 720 times 1. I'm taking this picture and trying to compare that one with the actual one which I'll open in my browser. So I'll just do it again. This is home. Sorry for the stupid names. I wouldn't call them like this in my production test, but for the demo purposes should be enough. So now what I'll do, I'll open the browser again with the specific resolution and compare it against my baseline. And now you will see that it works. Everything will be okay. And I'll see in my terminal that it will pass, hopefully. So it passed. For the ones who are not familiar with the, now I'm a bit lost, with the robot framework, this is the terminal where I see that it passed, but I'm not showing you the right one. This one is the one, the last one. So this is the message. And now I'd like to show you something what will simulate what will happen if it fails. So I will insert bug into Spotify website by manipulating how the website look like, inserting some JavaScript. It's not the real case situation, but I just wanted to have the Spotify a bit buggy visually to show you what would happen. So I just commenting out, this was commented. I just commenting out the insert bug keyword, which is method which inserts some JavaScript into the website and manipulate it in a way that it won't be visually correct. And let me try now to execute the code. I hope I will. So I will run the test again. This is the test. Check home page. Oh, not the right one. So opening browser, resizing into the specific resolution, manipulating the website, comparing that manipulated page with the one I test. And now I hope. So this is the page I compared with the one which is here. So this is the baseline, and this is the test. You probably notice where is the difference. If not, the tool itself shows you the differences. I basically remove the logo. So instead of running this manually, I let the robot framework to do it for me, so I could easily do the regression test, visual regression testing, by comparing these two results. And of course it fails. And in case of it fails, it generates, and the guys who know the robot framework, they might know that there is a nice report where you could go to the details and see what's going on there by basically clicking through the log. And you might see that this was the click homepage test. I start test, which is a keyword which consists of several other ones, like set Selenium speed. I just slow it down a bit because of demo purposes. Then I open the browser on specific URL, and I said this open the Chrome, and then I insert the bug. This was the JavaScript I executed to remove the logo, and these all are green because it passed. Then I set up the variables, and then I compare the screens, but screens were not same. That's why it fails. It took the actual screen of the web page. You might see the logo is not there, and also insert what is the difference. So for you, when you run it on within some pipeline, you might see immediately in your reports on the Jenkins or whatever you are using what happened, and deal with that. So this is just very simple demo. I focus only on one thing, and this is the visual. I'll show you something else. This is the other approach. Okay, I shall report. So this is over, then we have the second one. But before that, any questions? I'm not sure whether I'm clear enough. This is not a training of a robot framework. It might be too heavy, but I was trying to prepare something not really like Hello World, but hopefully it was clear. Any questions?
Can you please show the keyword compare screen?
Yeah, I could show. It's Python. Probably you do not need to know the details. It's completely open sourced, so you can easily go there on GitHub and download this code. And as I said, it's beta release. We know that there is some code smells we need to clean up. But anyhow, this is the code of that keyword, but it's built up in a way that it's library. So you do not need to bother at all with this. You just use compare screen, and there is a pretty nice documentation already. And as I said, still work in progress, but already this is the table with all the keywords, with some descriptions, parameters, and there are some manual to install, and there is some folder with the sample code, so you can see how the keywords works. But this is not all what we will share yet. We will share much more later. We are working on that, but we really want to show it now, because we are happy to involve first early adopters to help us to improve. So this is, I don't know, Michal, is it enough? Or any other question?
I think it's okay. Thank you.
Okay.
It's too complicated.
Too complicated? You mean the library or the code I was showing?
I mean the keyword compare screen.
Keyword compare is too complicated.
Yeah, for the first view for me.
Okay.
I'm really interested in.
Okay, so maybe I will explain the compare screen. Compare screen has just two parameters. One is the baseline. This is actually URL to the picture. And then the other one is where you want to save the comparison. But you might skip this one. So then you would just provide a baseline screen. And this baseline screen is compared with your browser.
I understand this. I mean that the implementation of the keyword in Python is.
But that's why we wrap it into the library, so you do not need to bother at all with that. You just need to understand these 7 keywords, and you can build up your own solution in your own way without understanding too much coding, as many other things in Robot Framework.
Marcel, is Richard, how does it actually do the compare? Is it pixel by pixel?
It's actually pixel by pixel, and now we are working on more intelligent way. So it'll be machine learning based approach, but this is not ready yet. And we are not sure whether it will be part of this library or we will build one extra for that more dynamic comparison. But let me show you the other example. Maybe it's a bit actually more complicated, but I wanted to show you that imagine that you have your own test cases where you test, for instance, the wizard to buy your new Tesla. And I build up just 2 test cases. One is order blue Tesla with autopilot, and the other one is order red Tesla with no autopilot. And for that, I implement 2 keywords. Consider this as a method where you provide some parameters. One is the color, the other one is the wheels, the other one is the interior color, and then whether it has the autopilot, yes or no. And this one, I was trying to make it really simple. So there is some parameterization here just to set up all the libraries I need and import all the things I need. Then there is something we call test setup. This is basically the method where I'm opening the browser and do some initial configuration of that. Then some variables, which is start URL where the application is. You might have the testing environment link here instead of the production one, and which browser I'm going to use. And for this one, this is a typical functional test where I just follow some screens, clicking on some buttons, validating some data, checking whether everything is there, and so on. And let me first just execute this one. I hope I prepared the right execution. Yeah, this hopefully will work. So this is the test case or test, where I just open Tesla screen, click on United States, then I select the model, it should be model 3, then I click on the button order now, and then I follow the wizard, you will see soon hopefully, and select some specifics which were parameterized within the keyword I was calling. So this is a pretty slow because I'm doing that with some setup of slowing down the Selenium speed. This will just basically go through that, and I will not submit the button because I didn't provide a credit card, and I don't want to be charged $100, I think, dollars as a initial order, or how it is set up. So, and this is actually I didn't close the browser because this is some history of debugging, but anyhow we would close the browser. And now I'm doing the same but with the red color. This is not important anymore. I'll just switch back to my IDE and let the test finish. But this is how you would structure your test cases. And your test cases would be probably implemented, or you would implement your keywords where you have, this is the order Tesla, this is the main keyword with some specific parameters like color, wheel type, interior color, and whether I want to have an autopilot or not. And you just go through that and implement some other keywords. And this is just functional test, nothing else. And now imagine that you have not 2 test cases as I do, but you would have 200 or 1000 test cases, and you would like to implement some visual testing within them. So what we could do, and this is not part of robot framework, this is general, any modern test automation tool approach. There is always something called test setup and tear down. So you always have, before some test case will be executed and some test case will finish, some cleanup and setup methods. And within this, you could build easily the visual testing. Actually, my tests, functional tests finished, and all 2 or both 2 are passing. So now I'll show you how I could extend these functional tests by introducing visual testing. I would do it by adding something extra, and I'll do this like into things. So I'll show here. This is flow 1. This is the old one. There is some setting. I could open first the setting. What I need to introduce extra is that I'll put some tear down procedure, which is a keyword or method which I'm calling after every test case when the test case ends. So I call this check visual. It's kind of method which compares the baseline with actual. This is one thing, and that's it for my test cases. You might see the test cases are not touched at all. if I compare now the test cases, order blue Tesla with autopilot, then I have my keyword Tesla, then there is a color. Sorry, I changed the color for this kind of demo, but the rest is same. And same is here. The only thing I need to do is implementing this visual check. This visual check is these, I don't know, 10 lines of code. So if you have 1,000 test cases, you would need to implement these 10 lines of code, and you extend your functional tests with visual checks. So easy it is. Of course, in Java it would be different, but I would expect that if your test cases are structured and designed properly, the approach could be used also in C#, Java, or whatever other languages you are using, Node.js, PHP, and so on. So I implementing nothing else than only comparing or creating the screenshot. So in case I have my baselines prepared, then I compare the screens with my baseline. If there is no baseline created, I am creating the one. So this will be done within the first execution. I'm building up my baselines. These need to be checked manually. And then I just executing and comparing my tests against these baselines. And I'll show you my baselines first, and then we will play with the demo. So these are my baselines. I hope it will. I'll first close these. So this is the final form I took the screenshot from for the blue one and for the red one. And now if I will execute the same command, but actually I prepare the script into flow 2. So I execute this one, and this will execute the functional testing again, but with one extra step at the end, which is taking the screenshots and comparing with the baseline. Hopefully it'll work. So I might stay and watch the robot to click through the browser, but I'm already not amazed anymore by the Tesla because I saw these pictures so many times now by preparing the demo and playing with that to make it hopefully clear that we could easily switch. But this is just nothing else, just following the same steps. So I'll switch back to my IDE to show you some more demos. So once this will finish, we would get the report, and I'll probably, hopefully this will finish successfully. And then I'll show you the first one already finished. Now it's starting the second one. And once this will finish, I'll show you the reports again, because this will hopefully be example of two tests which passed successfully. But what the application will change? What if the application will change? You need to rescreen all your baselines again. And I'll show you first something which will simulate a bug. So the screen will be different. I'll do it by just commenting out this and commenting this. So what I changed, if you compare the one above, I just changed the wheels. The wheels of the car will be set up differently. All the other things keep stay same. And this is not actually bug. I just simulating the difference. But it might happen that your visualization of your wheels changed, or some picture was removed or replaced by something else. and you need to test it, and you need to find out that it was changed. So this is something I now re-execute, and it will, hopefully it will be fail on the first case, and on the second one it won't. So I starting up the tests, and now I'll try to quickly open the report from the previous run to show you how it looks when everything pass. So this is the result. You might see this is first test case, setup, order Tesla, and check visuals. Same for the second one. The parameters for the order Tesla are different. If I just drill down, I could see all the steps like click button, select exterior, which is actually other keyword where I could find some more details and so on, continue. But this is boring. You usually don't do any checking of tests which pass. So you are happy, no maintenance, no bug reporting, everything is going well. But have a look now on that test which is ongoing now, and hopefully, yeah, it'll be soon done. Yeah. Now the wheels are different than the expected ones. So now it should fail, and we will see it in a console. So I'll switch back to my IDE, and the first one already failed. You might see also the difference. The difference is not so big. It's just, and this is a pixel by pixel comparison. It's really small, and I am not patient enough. So I'll go and show you already the difference. I hope this is not the one. This one should be the right one. So now you can see the difference. My tool showing me that what are the differences. One is that my wheels. Sorry for now jumping there and back. Let me do it. This is not the best. Maybe I will open it in something else. Open. Show in Explorer. Go. Okay, I'll not now bother with that. It would take. Anyhow, you might see that the wheels are different, but not only wheels, also some summary of that configuration is different. So this text is different. You could easily find probably these ones if you have the text validation there. And also the prices are different. So these are the visual changes. And a lot of these, I could imagine you might find by validation, like the assertion of the text should be there. And you can script all these things within your functional test, but it's not so easy to script this wheel comparison. And the tool is doing it by introducing just these few steps. And let me now do some other simulation. I would now decide that this one is the right new baseline. So what I do, there are two options. I'll just take this screenshot. Let me find the right one, not this one. I could take. So this one was the expected result, but we got this one. So instead of leaving this to be failed, I remove both of these. I remove the comparison picture. I don't care anymore about it, and I remove this blue one because this is not. It's not actual anymore. This one is not what I want to get from the test. So I removed my baseline, and now I re-execute only the one I changed. I could re-execute all the tests, but it would take too much time. So I will do it just in a way that I'll re-execute this one and the one with the new baseline required. So I re-execute it first to get the new baseline. I don't want to do it manually. So, paste, no. So, Now, if I didn't make any mistake, then it will execute only the one test case we need to re-execute. And in this time, my code, instead of comparing, will check whether there is a baseline. If there is no baseline, instead of comparing, it will create the baseline. So it won't execute the test because there is no baseline, and not compare the expected and actual result, but create a new baseline. And next time when I will execute that, it should compare against the new baseline and it should pass. I hope it was clear. Now it's still running, but there should be new picture here soon, or the red one. This is the red Tesla baseline, and once this will finish, we will get into our output folder, but it could be parameterized and it could be saved somewhere else, the new one. Okay, here we go, and refresh. Where is the refresh? Reload from down. Now the new one already contained the new wheels, so I have a new baseline, and once I will execute the test again, it won't create the snapshot, it won't create the baseline, but it will compare with my new baseline and it should pass. I could execute it again, but we are running out of time and I don't want to delay the question and answer. I hope I showed everything from my demo. Of course, we could show, or I could show you demo again, reports again, but it would be the same. If it's pass, there is nothing to see. There is a just log there. And if it wouldn't pass, if it actually fail, then you could see the difference between the screens. So let me switch back to the slides to summarize. Are you still with me? There are still some people, so hopefully you find it at least a bit interesting. I will skip this slide. It's just for the guys who are really interested in more details to discuss in some one-to-one session and explain more details how it works. But I would like to, before I will thank you that you join us, also ask you for help. I would really appreciate if you are interested to go on our GitHub, try to install and play with the Watch UI library. We are all the testers, so I believe you will find a lot of bugs, and I believe you will find a lot of great ideas how we could improve the library. We would like to share this for free because we found last 3 or 4 years that this is really annoying doing this testing manually. And we had a few small tools built up ad hoc for specific customers, but we would like to have something which is reusable and shareable with all other guys dealing with the visual testing. I would like to also encourage you to follow us on LinkedIn. We will share more details and more update about these topics and many other interesting ones there. We are preparing a lot of webinars and a lot of online events as well. So if you are not following us on LinkedIn, I think it's a good opportunity to find something new about us or what's going on, what we are preparing. Of course, there is Facebook and Meetup group as well, so you can join us there. If I know that some of you guys came today via that one. So this is my wish, or this is something where I would like to ask you for your help. I believe that this Watch UI has a big potential because I saw a lot of pains coming from the projects and how we dealt in the past with that. So if you have any idea, we are happy to collect them and probably incorporate to the tool. The other topic I would like to share with you before we leave, we could also help you to implement these kind of tools via, as I said, one-to-one session, sharing some more details how to start, or we could come to you for one day and spend one day with you and with your team and just set up these simple things so you can easily scale up with that. Not only with the visual testing, but with test automation in general. We helped a lot of companies to start and scale. There are some organizations, they do a lot of automation testing, and we are happy to be part of that journey and that story. If you would be interested in more topics around the trends and how the test automation and these topics are changing, I'm having a talk, I think in 2 weeks in Slovak language on one testing conference, which will be held online, and I think it's free. It's called Test Tech, so you might join us there. It's first week of April, I think, so it's probably week after the next one. If you find this topic I shared interesting, I'll do the same in 3 weeks in Slovak. So if you have your colleagues interested in the topic, I'll do it again in Slovak. Maybe it'll be more fluent than my English. And we also do some more extended support. We have basically 3 other approaches how to establish test automation in our customers' organizations. But I don't want to bother you with these ones, only for the guys who would like to be or who would like to try that or help with that. We are happy to talk into more details. So I would like to thank you and wish you a nice rest of the evening. I hope you find some interesting ideas. I hope you are inspired to extend and improve how you deal with the visual testing. This is not the only way how to do that, but I hope I showed some principles and patterns you could easily use within any other modern testing tools. So thank you for coming, and now I'm open to discuss any questions or repeat something I showed during the demo or during my talk. There are some. Yes, we are here. Okay, so if you have any question, just unmute and ask, or if you hesitate to talk or your mic don't work properly, you could use your chatting window on the right side. For the guys who are not familiar with the Microsoft Teams, there is an icon, I think almost in the middle, this one, which will open your chatting window. I found that some guys who don't use Teams and they use rather Zoom or something else, they might be lost with that UI. But this is the button. For unmuting, you have this button, but I think it's obvious and clear. So any other question or comments or recommendation or wishes? Okay. I'll wait 3 more seconds, and then I'll just thank you again. Oh, something is coming. Okay, thank you, Josef. So thank you very much for coming for this evening session. Hopefully we will see soon on some other online session, and hopefully not only online, but in person as well. I'll share with you my last wish from that session today, and this is the feedback form. I would really like to get your feedback, because this is the best way how I could improve the slides, myself, demo, and all the other things, and maybe also share this feedback with some other colleagues who will do the next sessions. So thank you very much and have a great evening. See you soon.